Today we did examples with one specific formula. Do you guys understand that that formula is for interest when there's no compounding involved, when it's just a yearly interest rate and they give it to you once a year? The problem that you looked at in the investigation used this formula, okay? It also has a yearly interest rate, but it specifically is being compounded a certain number of times per year. Is that okay with everybody? So the interest rates are all yearly, but the question is, do they just give me the lump sum of the interest one time a year? That's what we looked at yesterday. Or do they break the interest, see the rate, broken into a certain amount of parts, and they give me the parts more often, not just every year, but however many times they broke it up, that's how many times I get that interest, okay? So if it says it's compounded a certain number of times like it did in the investigation, you would want to use this formula, okay? So then, like we said, you guys figured out that E value on your calculator. I'll write a few decimals out on here, and then I'll talk about, if we're using graphing or something, exactly what to use for E. So if we were graphing or something like that, we would just kind of stop around 2.7. But here are the other decimals for you guys. Okay. And even though it looks like it keeps going 1828, it's an irrational number, so it's a never-ending, non-repeating decimal. Okay. And so the reason we use E is what you guys saw. What if we compound it to the maximum amount? Like compounded continuously. Like what is continuously? Who knows? Like every second, every millisecond, something like that. It's kind of like an undefined, like how could it possibly even calculate that? If it was really different, it probably couldn't calculate it. But you guys saw that as you raised the number, it did get bigger, but then eventually it didn't get that much bigger, right? It kind of stopped at this certain value. So when they say compounded continuously, they're just saying, hey, we know it reaches a maximum, like there's a certain point that compounding more doesn't really make a difference in the money. So we're just saying we're giving it the most compoundings possible, so to speak. Is that okay with everybody? All right. So if I hear interest and it's yearly and I don't hear anything about compounding, I use the formula from yesterday. If I hear interest being compounded and they say a word that means a certain number of times, monthly, what does monthly mean? 12 times a year, right? What does like quarterly mean? 4 times a year, okay? When I hear something that means I can say, oh, that means this many compoundings, then I should be using the formula with N in it, like you guys did in your investigation. If they say compounding continuously, I would want to take that formula and max it out, and that gives us this new formula here, okay? Since things just approached E, they manipulated the formula with E in it and found that rather than doing what you guys did and having to just increase the number till you don't see a difference in the amount of money anymore, we can rewrite the formula this way and it takes all of that into consideration. So does everybody understand there's 3 different ways that we can calculate new amounts after interest? One is what we talked about yesterday, simple interest, only annually, nothing to do with compounding. One is if you compound a certain number of times, and then you'd want to use the formula with N in it because you know the number of times. And one is if it says compounded continuously, like this does right here. That is specifically when you want to use the formula with E in it, because continuously doesn't really have a definition. It just means as much as possible, and that's what you saw the value approach was E. So E is representing as much as possible. Is this okay with everyone? So 3 formulas, not 1 like we thought about yesterday, depending on the situation. Okay. So we're going to look at this if we were finding compound interest on a principal of $10,000 at 8% interest. And we're going to find, actually, cross out this. We're going to find the amount. We have to be careful how we ask the question. Our formulas aren't calculating just the amount of interest. They are using the original amount in there as well. So they are saying this is the total you'll have at the end. Not the amount of interest added on, but the total, okay? So if it's compounded continuously for 1 year. So because it says compounded continuously, I should immediately know to use this format of the formula to take into account what I've invested in the interest and the rate. And so this was $10,000 is my principal. My rate is 8%, and my time is 1 year. And when you enter that into the calculator, just be really careful that this all ends up in the exponent on E, but you can enter it in just how it looks here. And when you guys do that, again, just be careful. I mean, with 1, it's not a big deal, but with numbers other than 1 year, you'd want to make sure that doesn't end up multiplying the whole equation, but just ends up multiplying in the exponent. And you guys should get an amount of $10,832.87. Okay. So that would be pretty nice. If you found an account that compounded continuously with this nice interest rate of 8%, you put $10,000 in there, you don't touch it for a year, and all of a sudden you have $10,832. Okay. All right, and now let's look if we compounded it continuously for 10 years. So this is the same formula and the same interest rate. All we're doing is upping the amount of years that we kept it in there. So this is where you want to make sure that both your 0.08 and your 10 end up in the exponent, or we would end up with pretty different answers. And so here you should get $22,255.41. Okay. Is it okay with everybody why we need to use this formula and not another formula, and where we're plugging things in? Okay. So you do have to know some formulas. Okay. So like our class so far, you have to know a lot, but it hasn't been like a very much strict memorization of formulas. In this section, you do have some formulas you have to know, okay? All right, any questions on these two problems? All right, so now let's talk about graphs, and then that's it. And then you guys will actually have some time to work on your homework, okay? So I am gonna do these graphs with transformations, but the base is E. Okay, so it's a little bit weird because that's kind of a crazy number. So what we're going to do is we're just going to be really familiar with the graph and really not do very many points at all, like 2 points. That's it, okay? So this would be the parent function if you were graphing with a base of E. E is a number, I mean, technically you could graph with a base of pi, and you would treat pi like 3.14 and approximate it like that. Remember that E is about 2.7, right? So here are the only 2 points I'm really interested in using if I know what a graph looks like, okay? What I'm really interested in using is a 0 and a 1 for a really difficult number. If this was not E, if this was 2 or 3 or a fourth or 10, I would use -2, -1, 0, 1, and 2 to get a better idea of the shape. I'm saying it's acceptable in a case like this just to use 2 points, specifically because the base is an irrational number. Does everybody understand that? With your rational numbers, the normal graphing with transformations, you guys should use more points and have more exact graphs, but it's acceptable in this case to do this, okay? And the reason it's acceptable is because we should have a good understanding of the graph. If E is about 2.7, okay, then is this going to be growth or decay? Growth, right? So I should know that I expect this kind of graph, and I'm just giving myself 2 guiding points here to do it, okay? So because it's a parent function, we expect the asymptote at y equals 0, and every parent function for exponentials has a point where when x is 0, what is y? 1, okay, because anything to the 0 power is 1. And then that one other point is just going to help me a little bit understand the steepness of the graph. Because E is about 2.7, then E to the first power, I'm going to say, is about 2.7. Is that okay with everybody? And I'm just going to plot those 2 points. In this case, I think that that's acceptable. So that just kind of gives me the steepness of the graph. I'm going to put in the asymptote, and I'm just going to draw a curve based on those. So if I'm asking you to graph with a base of e, I am still asking you to do your exponential graphs with transformations, but I'm kind of giving you leeway to do a couple of approximate points rather than a lot of exact points. Is that okay with everybody? Because of the irrational number. So then when we look at the one next to it, it has a base of e, so this is good practice with skill 1 if you were struggling with graphing with transformations. It has a base of e, so we would use the same type of parent function, right? But it has a bunch of transformations. So it has a reflection over the x-axis, a vertical stretch of 2, a horizontal shift to the left 1, and a shift up 3. Okay? So in my chart, x is getting moved over 1. Y is getting multiplied by -2 and then has 3 added to it. Okay. And again, I'm just using those two values, 0 and 1. So 0 gets shifted to -1 and 1 gets shifted to 0. And then the y values that I had there before were 1, which gets transformed still to 1. And then I had 2.7. This is why it's annoying and why we're only doing 1 point. We're going to do one arithmetic calculation with this approximate of 2.7. 27 times 2 is 54. So 2.7 times 2 is 5.4. Okay. So that would be -5.4 plus 3 would be -2.4. Okay. This is the only reason why I'm giving you guys leeway. Okay. Because I don't want you trying to figure out what 1 over 2.7 is and spending all this time trying to get a good approximation of that and then trying to take that crazy decimal and then transform it. I think a couple points is going to be okay if we're using e, right? So I'm going to put my asymptote in. Remember, that should now be at 3 because of the k value adjusting this graph, moving it up 3. So there's my asymptote, and I have a point at -1, 1. And I have a point at 0, -2.4. And so then I can kind of see how to fill it in from there. If you're stuck, then you really just got to go back and study the curve a little bit more. Remember, the curve is always on one side of the asymptote, so clearly this one's below the asymptote. And it curves so that one end is approaching and getting like the asymptote, and the other end is going away from the asymptote. Based on where these points are, it's going to come back towards the asymptote on this side, and it's going to go away from the asymptote on this side. Okay, so I'm kind of seeing this as the curve going away from the asymptote, and this will be the side that goes towards the asymptote. Okay. And then from there, you guys could figure out all the same characteristics if you were asked of a graph. So point being, if you're using e, it is just a number, so try to use it like we would do all of our other graphs. However, I don't want you guys to spend a million hours trying to do these things with decimals and crazy decimals, so we're just letting you use 2 points instead of 5. You don't get as good of an idea for the curve, but from what I've seen for what you guys have to do in the future, this is good enough. If you have a base like e, you just have to understand the positioning of the graph and be able to see characteristics of it, and I think we can see all of that later. Okay? Is this okay with everybody? Any questions about it? All right, so why don't we let you guys get some homework done. You guys have a homework quiz on Tuesday. Okay, so you want to be all caught up. I'm specifically not putting